Hello everyone, welcome back to our channel that is QPOL. Students, my name is Anjali Mishra. Here we cover different concepts of science. So students, this video is particularly going to be about solving all the questions which are there in different pages of chapter 3, including the exercise questions as well. So we are going to start this video with the questions, like the in-text questions that are given in page number 40. Page number 40 questions. So the first question says that we have to give an example of a metal. So basically, students, this question has been divided into 4 parts. So let's talk about the first part. Question is saying that give an example of a metal which is a liquid at room temperature. So obviously, we have covered this thing while we were covering physical properties of metal, that mostly all the metals are solid, but the exception is mercury. Here, mercury is a metal, but it remains in liquid state at room temperature. Then the next one is, we have to name a metal that can be easily cut with a knife. So the answer would be both sodium, that is K, and potassium, that is K, and sodium, that is Na, are the metals which can be cut very easily with a knife. Next question is, a metal that is the best conductor of heat, and the answer would be silver. Like, although copper is also a very good conductor of heat, but if we have to choose between these two, we'll say silver is the best conductor of heat, but we prefer using copper because it's cheaper and it is easily available. Like, although silver is also easily available, but if we'll compare which one is costly and which one is cheaper, the answer would be copper is cheaper. Now, the last part of the question is, we have to name one metal that is a poor conductor of heat, and the answer is going to be mercury and lead. Both of these metals are poor conductors of heat and electricity. Apart from this, all the metals, let it be sodium, potassium, lithium, silver, copper, aluminium, platinum, these are very good conductors of heat as well as electricity. Moving on to the next question, which is given in, I think, okay, the next question is, we have to explain the meaning of malleable and ductile. So students, while we were covering physical properties of metals, we have learned that metals can be malleable, and at the same time these are ductile as well. So if I say malleable, that means metal can be beaten to sheets. And if I say metals are ductile, that means they can be drawn into thin wires. So that is how we can describe that. If we say that metals are malleable, that means metals can be beaten into sheets. This is said to be malleable. And ductile means that metals which can be drawn into wires. So we just had two questions in page number 40. Now we will be covering questions which are there in page number 46. So students, the first question says that why is sodium kept immersed in kerosene oil? So we'll answer this question by saying that sodium is a reactive metal. So if I say that sodium is a reactive metal if it is kept open. So here I'll write it as if it is kept open, it will react with oxygen to explore and it can also catch fire. So I'll write it as if it is kept open, it will react with oxygen to explode and catch fire. So sodium is kept immersed in kerosene to prevent their reaction or reaction of sodium with oxygen. And it's not just about oxygen. We keep sodium immersed in kerosene oil so that it doesn't react with oxygen, moisture, carbon dioxide gas, etc. So this should be our answer. Moving on to the next question. Students, the next question says that write equation for the following reactions. It's going to be the second question of page number 46. So, students, the next question says that what type of equation or reaction will occur if steam is reacting with iron. So steam obviously means water will react with iron. So what type of product we will get? So this is the first part of question number 2 of page number 46. So we have iron reacting with water. So the product would be iron oxide plus there will be liberation of hydrogen gas. So we'll answer this question by saying that whenever iron reacts with steam, it will form magnetic oxide of iron with the liberation of hydrogen gas. Moving on to the next part of question number 2, we have to answer what will happen when calcium and potassium will react with water. So, when calcium, that is Ca, combines with water, that is 2H2O, the product is going to be calcium hydroxide, means CaOH2 plus there will be liberation of hydrogen gas. Then we have the last reaction, which is what will happen if potassium reacts with water. So potassium means capital K reacting with water, that is H2O. The product is going to be potassium hydroxide, means KOH, plus there will be liberation of hydrogen gas. So this is how we have to answer about what type of reaction will occur if um, iron reacts with steam, or we can say what type of reaction will occur if let's just say calcium is reacting with water or potassium is reacting with water. Now we have our next question, that is question number 3 of page number 46. Hmm. So, sample of 4 metal are there which were taken and added to the following solutions one by one. The result have been obtained is tabulated as follows. So, let's just answer question number 3 of page number 46. So it's like we have got around 4 samples, like 4 metals. They are named as A, B, C, and D. And then, okay, one second. Let's just name these metals as A, B, C, and D. And then we'll allow these metals to react with iron 2 sulfate and the second one is copper 2 sulfate. So, uh, as per the thing which is given in the table, we know that metal A, when combines with iron 2 sulfate, there will be no reaction. But with copper 2 sulfate, there will be displacement reaction. With the second metal, no reaction with copper 2 sulfate, but there will be displacement reaction with iron 2 sulfate. Then, in case of third metal, there will be no reaction, and same goes with the fourth metal. That is, here also there is not going to be any type of reaction when this metal D will react or combine with iron 2 sulfate or copper 2 sulfate. So we have to use this table to answer the following questions about metal A, B, C, and D. So the first part of the question says, like third question, first part says, which is the most reactive metal depending upon the information which was provided in the previous table. So we'll answer this question by saying metal B is the most reactive one. Reason being, it gives displacement reaction with iron 2 sulfate. Second question is, what would you observe if B is added to the solution of copper 2 sulfate? So we'll answer this question by saying that when metal B is added to copper 2 sulfate solution, a displacement reaction will occur, because of which blue copper sulfate solution will fade and a red brown deposit of copper will be formed on metal B. So if metal B combines with copper sulfate, there will be a color change. So it will form metal sulfate, which will have a red brown deposit of copper on metal B. So this is the type of reaction. I'm sorry, this is supposed to be metal B, and this is how the reaction will go if metal B combines with copper sulfate solution. Lastly, we have the third part that says arrange metals A, B, C, and D on the basis of their order of decreasing reactivity. So we'll say that metal B is mostly like out of these four metals, that is A, B, C, and D, metal B is highly reactive because it was displacing iron 2 sulfate solution. So your statement should be metal B is the most reactive one because it displaces iron from its salt solution. Comparing it with metal A, it is going to be reactive but less than that of B. So metal A is less reactive because it displaces copper from its salt solution. Metal C is still less reactive because it can displace only silver from its salt solution. And then the last one is D. So out of these four metals, that is A, B, C, and D, B is the highly reactive one and D is the least reactive one. And that is how you people can answer this question. Moving on to the next question of page number 46. The question says, which gas is produced when dilute hydrochloric acid is added to a reactive metal? Write down the chemical reaction when iron reacts with dilute sulfuric acid, which is H2SO4. So we will say that whenever dilute hydrochloric acid is added to a reactive metal, hydrogen gas is liberated. Here it would be like hydrogen gas is liberated. Okay. And then to answer about what type of reaction will occur when iron, that is Fe, will combine with dilute H2SO4, that is sulfuric acid, the product would be like FeSO4 plus hydrogen gas. Moving on to the question number 5. Students, question number 5 कहता है that what would you observe when zinc is added to a solution of iron 2 sulfate? Write a chemical reaction that will take place. So अगर हम reactivity series को students recall करें, so we can say that out of zinc and iron, zinc is more reactive than iron. Therefore, whenever there will be a reaction between zinc and the salt solution of iron, zinc will definitely displace iron from its salt solution. So the color of ferrous sulfate is pale green, but after the reaction will get completed, it will turn into colorless. So the reaction would be like FeSO4 plus Zn makes ZnSO4 plus Fe. So यहाँ पर you people can write it as iron sulfate is like light green in color, and then zinc sulfate would be like colorless. So this color change will indicate that this reaction has now been completed. Moving on to the next page, which is page number 49. Students, we have got a very first question which says, write the electron dot structure for sodium and oxygen. So we'll write it as students, basically electron dot structure का मतलब होता है that we don't have to show all the electrons which are going to be there in the different shells of that particular atom. We just have to answer about the last shell, or we just have to show that how many electrons are going to be there in the last shell of that particular atom. So for sodium, since its electronic configuration is 2, 8, 1, this would be like 1 added to oxygen, that is O, and here it is going to have 6 electrons in its outermost shell. But students, having just one sodium atom will not make sodium oxide compound. So for that, we'll use one more. So when reaction will take place, both the sodium atom will combine together. They'll acquire plus charge, because this is indicating that both of them has now lost their electron which was there in their outermost shell. And talking about oxygen, since it has gained 2 electrons, so its structure would be like 1, 2, 3, 4, 5, 6, 2 dots over here. Make sure कि आप लोग dots ही draw करें, crosses ना draw कर दें, because then it will create confusion कि सब चीजें तो एक जैसी हैं. So how it is showing that oxygen has gained extra electron of sodium. So this would be like 2 minus, and the compound would be like Na2NO. So that is how sodium oxide is formed, and this is how you have to draw its electron dot structure. Moving on to the next question of this page. Second question says that we have to answer about formation of magnesium oxide. अब देखिए students, magnesium means a compound where there will be 2 electrons in its outermost shell. When it will combine with oxygen that has around 6 electrons in its outermost shell, combine करने के बाद magnesium will lose all the electrons, and then it will acquire a 2 plus charge, and on the same segment this oxygen will now have 8 electrons. So again 2 dots over here, and then 2 minus charge. So they are having equal number of opposite charges, therefore the formula of the compound would be MgO. But in case of sodium oxide, we have got 2 sodium atom, otherwise oxygen तो stability attain ही नहीं कर पाता, therefore वहां पर उसका फॉर्मूला था Na2O, but here it's just going to be MgO. अब स्टेटमेंट्स क्या लिखते हैं उसकी बात करें, so you people can write it down as when magnesium reacts with oxygen, the magnesium atom transfers its 2 outermost electron to an oxygen atom by losing 2 electrons. The magnesium atom form magnesium ion, and by gaining 2 electrons, the oxygen atom forms an oxide ion. So here we have magnesium ion and oxide ion, both of them will combine together in order to form magnesium oxide. Moving on to the last question of this segment. It's question number 3. The question says, what are the ions present in these compounds? यानी अगर सोडियम ऑक्साइड है, बेसिकली अगर सोडियम ऑक्साइड फॉर्म हो रहा है या फिर मैग्नीशियम ऑक्साइड फॉर्म हो रहा है, सो इस केस में आयंस कैसे होने वाले हैं? सो वी कैन आंसर दिस क्वेश्चन बाय सेइंग कि सोडियम ऑक्साइड के केस में सोडियम आयन and oxide ion will be there, and in case of magnesium oxide, magnesium ion and oxide ion. So this is how we can answer this question. Moving on to the second question of page number 49. Question कहता है students that why do ionic compounds have a high melting point? So we can answer this question by saying that ionic compounds, जब मैं कह रही हूँ आयनिक कंपाउंड्स, आप लोगों के मन में कोई एग्जाम्पल आ रहा है आयनिक कंपाउंड्स का? चलिए एग्जाम्पल ले लेते हैं, सोडियम क्लोराइड. It's the very commonly used ionic compound. So when this sodium chloride combines with no, basically if we talk about sodium chloride, you can see that we have sodium and chlorine, जिसमें एक मेटल है एक नॉन मेटल. सो ऑब्वियसली सोडियम आयन जब फॉर्म होगा इट विल कैरी पॉजिटिव चार्ज, और क्लोराइड आयन इज द थिंग विच विल बी कैरिंग नेगेटिव चार्ज. तो क्या होगा? वी कैन से दैट these are the ones I'm sorry, these are the ones which has both positive and negative charge. Hence there will be a very strong force of attraction. क्यों? बिकॉज साइंस कहती है कि जब भी दो चीजें ऑपोजिट चार्जेस कैरी करती हैं उनके बीच में बहुत स्ट्रॉन्ग अट्रैक्शन होता है. सो हियर सिंस दे आर कैरिंग ऑपोजिट चार्जेस, they will have a very strong force of attraction between them. So this will need high amount of energy when we have to break that bond. So if we are putting in extremely high amount of energy in order to break this bond, we can say that these compounds have got high melting point. So the last statement would be this make expenditure of lot of heat to break this force of attraction. Force of attraction. Therefore, higher melting point. Or you people can write the whole statement by saying that therefore this is the reason why do we say that ionic compounds have got higher melting point. Moving on to the next question which is there in page number 53. So it's page 53 now. So students, the first question is all about defining the following terms. First one is mineral. Second one is ore. And then the last one is gangue. So we will define mineral by saying that mineral can either be an element or a compound which is found naturally in the earth crust. Example could be alums, etc. Talking about ore, ore are a type of mineral from which metal can be extracted. Best example is bauxite ore, which is an ore of aluminium, and its formula is Al2O3 dot 2H2O. Then we can say that all minerals are not considered as ores, but all ores are minerals. Lastly, when we have to define gangue, we can say that ore that are mined from the earth are naturally contaminated. That means these are impurities. So these ores can be contaminated with sand, rock material, or dust particles. So these are the impurities which are present in the ore and they are called as gangue. So this was about question number 1. Now question number 2 says that we have to name 2 metals which are found in the nature in the free state. Answer is very simple. It's going to be gold and platinum, because these are two such metals which are least reactive and also these are found in the free state. Moving on with the next question, that is question number 3. And this question 3, students, is also the last question of page number 53. So the question says, what chemical processes is used to obtain a metal from its oxide? So we'll answer this question by saying that reduction method, one second, reduction method is used to obtain metal from its oxide. Example, if we have zinc oxide, the zinc oxide, when it will combine with carbon, the product would be zinc and carbon monoxide. On the other hand, if we are having lead oxide means PbO. I'm sorry. So PbO, when it reacts with carbon, it forms the metal in its purest form and then carbon monoxide. So that is how we can perform reduction method by reacting these metal oxides with carbon. So this whole reaction is what is called as reduction with carbon. Now we will be covering questions which are there in page number, let's say, 55. So page 55, question 1. Question says that metallic oxides of zinc, magnesium and copper were heated with the following metals. So we have metal oxides of zinc, magnesium and copper, and these were heated with zinc, magnesium and copper again. So we'll answer this question by saying that a more reactive metal will displace a less reactive metal from the oxide. So out of zinc, magnesium and copper, we can say magnesium is the most reactive one. Then we have zinc, and the last one is copper. So the displacement reaction will take place when zinc oxide, I'm sorry, when zinc oxide will react with magnesium. So the product would be magnesium oxide and zinc. Then there will be no reaction when magnesium combines with zinc, magnesium, and copper. And lastly, if we talk about copper oxide, because copper is least reactive than that of magnesium as well as zinc. So copper oxide, when it will combine with magnesium, the product would be magnesium oxide and copper. And same goes with zinc as well. Copper oxide reacting with zinc forms zinc oxide and copper. So students, to answer these questions effectively or efficiently, it's important for you people to know that which element is more reactive and which one is moderately reactive and which one is least reactive. इसके बाद it will become very easy for you people to answer things regarding कि कौन सा वाला ज्यादा इफेक्टिव होने वाला है, कौन सा वाला कम इफेक्टिव होने वाला है. Now we have our next question that says, why which metal do not corrode easily. अब corrosion हमने देखा मीन्स अ प्रोसेस जहां पर एक ब्लैकिश ब्राउनिश सी लेयर फॉर्म हो जाती है ऑन द आउटर सरफेस ऑफ मेटल सच एज आयरन. लाइक आयरन तो मोस्ट कॉमनली अफेक्टेड है, बट कुछ ऐसे भी मेटल्स हैं जिनमें corrosion नहीं होता है, एंड दोज मेटल्स आर गोल्ड एंड प्लैटिनम. Now we have our third question. And the question says, what are alloys? So we will answer this question by saying that alloys are homogeneous mixture of a metal with another metal or a metal with a non-metal. So this is what is called as an alloy. And with this, we have covered all the questions which were there in page number 55. And now is the time to start off with questions which are there in the exercise part. So students, the questions which are there in the exercise part, those questions will be covered in a separate video so that it doesn't create much of confusion. I hope this video would have been helpful for you. So with this, we'll end video here and we'll see you in the next video. Thank you.